All right, pre-calc B. Hey, this is a ton of information. You can pause this at any time and just kind of stare at it. Again, if you look at the whole thing, I tell my students, you know, look at the tree, don't look at the forest. If you look at the forest right now, you'll be intimidated to even walk through it. One tree at a time, let's chop it down. You guys ready? So the first thing I'm going to say is this. On 1/6 day 1, they give you at the top of the page this actual equation. Now, a student like a couple days ago, I think it's Taylor Guy, bless your heart, Taylor, she said, hey, I'm thinking about taking that A and distributing it through. And this is not what your brain should be entertaining. So I'm going to throw in a little exponent there. And just so you know, I could have put a 3 there, a 4 there, a 5 there. It doesn't matter. These are the rules of graphing regardless of the actual function or graph or equation that's given to you. Remember, you were given 12 basic graphs. Some of them are basic. And 1/6 is going to start dealing with the 3 basic graphs. For example, maybe 4. Like y equals x squared is our parabola. Y equals the square root of x, kind of looks like this. Y equals x cubed, kind of looks like this. And they might kind of talk about the absolute value of x, because that's not a big deal. That just looks like this. Those 4, we should be able to move those around depending on what A, B, C, and D are. The other ones get a little tricky, so pre-calc is going to kind of come off the gas pedal a little bit. Concentrate on these easier ones. Let me erase this a second. All right, so back to this. Why did I put that squared there? Because according to PEMDAS, you then could not distribute the A through there. I don't want you entertaining that idea. There needs to be something there so that we can learn about what the rules are for the letter A. And as you can see, we're going to practice a few of these rules, but let's go through the rules right now. Right here, rules for A. If A is negative, you're going to reflect it over the x-axis. If A is a fraction, there's going to be a vertical shrink. We're going to talk about that. If A is a whole number, there's going to be a vertical stretch. So if this is like a 2, there'd be a vertical stretch. If this is 1/2, there'd be a vertical shrink. Let me go ahead and go on to letter B. If B is negative, then the entire graph would then reflect over the y-axis. Now, I put this word here, crosshairs, because if you're a hunter, you know that crosshairs look like this, and that's going to be significant, okay? So here's our original crosshairs, our XY axis. There's our target. I'm going to refer to this when we get down to a couple of these examples, so keep that in your head. But there's another thing. If B is negative, it flips over the y-axis. Don't forget your crosshair rule. We'll get to that. And it reverses the plus C or minus C rule. So the rule for C is, if it's a positive C, it's going to move it left. Just the opposite of what you would think. If it's a negative C, then it would move it right. Now, there's a big, long reason for that. If I have you in class, ask me to explain it, but I'm not going to take up this video to do that. And then D is something outside of the parentheses, or if this was a square root and it was like x plus 2, like plus 4, and that's outside the square root, then that would be our D. And if it's a positive, you just simply go up 4. If that's a negative 4, then you would go down. So those are the general rules. Now let's go ahead and try to apply these rules to these 4, and I might add some things to it. So there's our graph. And the first thing we're going to do is remember that this general graph looks something like this. Because if we put 1 in for x, and we take the square root of x, it'd be 1, 1, right about there. If we go out to 4, like if we let x be 4 and take the square root, it'd be 2. You can see that it just doesn't go up very high. But anyways, so now what does this negative do? Well, that's our A. That'd be negative 1. How do we know it's A? It's out in front of our parentheses, or it's out in front of our square root. So that would take this one and it would flip it over the x-axis. So it would look just like that. Okay, so this is example 1. I'll get out some different colored markers so we don't get too confused. Example 2. Whoops. This is example 1. This was our second example. So now example 3. we simply have to take our original one and apply this rule. Well, here's minus 2. I know your instinct is to think, oh, that's going to go left 2. It's just the opposite. If it's a negative c, you're going to move to the right. So you move this entire original graph right 2, so it looks something like this. And then here's example 3 right there. I'm going to try it. Hopefully the screen marker works. Now we got a whole lot going on here. So again, I'm comparing this one to the original. So really, what I'm going to do is take this off so it doesn't confuse you. Take that off so it doesn't confuse you. And now here we go. We got to make the necessary adjustments here. And again, you can do things in different order. And so what I'm going to do is I'm going to go ahead and, well, let's just follow the rules. So let's go here first. Well, that's my b, because it's underneath the square root, so that's a negative. What's my rule? Well, if b is negative, it's going to go over the y-axis. So here's my y-axis. So the first step would be to go like this. And then I got a negative 2. And remember, if b is negative, it reverses the plus c or minus c rule. So you have to think like double thought. Negative 2 would have been right 2, but because this is negative, it now moves it left 2. So I have to move this left 2, so now I'm to there. I'm going to go ahead and get rid of that. And then I got to move the whole thing up 3. So 1, 2, 3. And there's my final graph, and that would be 4. Okay? Now, what I'm going to do is I'm going to go ahead and I'm going to throw in a 1/2 here. Okay? And if I did that, now, see how much time I got? Plenty of time. Now that that is a fraction, my rule is if a is a fraction, there's a vertical shrink. So how would we draw that? Well, it just wouldn't go up as fast. Vertically, it's going up slower. So it would go like this. Or maybe, if you're a perfectionist, you'd say, well, it'd go up a little bit slower. I'm not going to get too worried about like the perfectionistic part of the drawing, just kind of get the gist. But now the question is, how do I say this? Well, I'm going to say that was vertically shrunk. And here's where a lot of students get a little confused, and I get it. So let me ask you a question. 10 over 2, what does that equal? I'll give you a second. It's 5. What if I went 10 times 1/2? 5. On this one, I divided by 2. On this one, I multiplied by 1/2. Regardless, I took the original number and I made it smaller. I took the original number and I made it smaller. So somebody might say vertical shrink by 1/2, but another student might say by 2. I accept both of these because this student's thinking division, this student's thinking multiplication. Both of them are fine. So when you get into the world of shrink, you can use either option and just be aware of that. Okay, there are a lot more sample problems where that comes from, so stay tuned. This is the pre-lesson just to get you warmed up. And then I'm going to do the packet lesson and apply all these rules to your packet lesson. 1-6, day 1. Good luck.